In this exercise, we're presented with some information about the very strange University of Erewhon. In the university, all students are assessed on 2 assignments. The first assignment has 3 possible marks, either 1, 3 or 6, and the second assignment has only 2 possible marks, 1 and 2. And we have a joint distribution of students' performance in those exams provided in the table. Now, the very first question that we're asked asks us to calculate the expected values of x and y in this problem. But in order to get those expected values, we first of all need to construct from this joint distribution the marginal distribution. Now remember, we can use the law of total probability to say, for instance, the probability that x is equal to a particular value, let's say little x, is equal to the sum over all possible values that y takes of the probability that x is equal to that little x and y is equal to little y. That's provided all the pairs of outcomes are mutually exclusive. In this case, it's not possible to have 1 and 1 and 1 and 3 occurring at the same time. So in order to find the probability that y is equal to 1, we just add up all of the joint probabilities where y is equal to 1. So the probability that y is equal to 1 is 0.1 plus 0.2 plus 0.3, which is equal to 0.6. Similarly, the probability that y is equal to 2 is equal to the sum of all of the joint probabilities where y is equal to 2, so 0 plus 0.3 plus 0.1, which is 0.4. We can do exactly the same for x. To find the probability that x is equal to 1, we add up all the joint probabilities where x is equal to 1, we get a probability of 0.1. Similarly, for x is equal to 3, we get a probability of 0.5, and for x is equal to 6, we get a probability of 0.4. So now, in order to calculate the expected value of x, or the expected value of y, remember the expected value of x is just the sum of the product of the probability that x is equal to a particular value of x times by each particular outcome. So in order to calculate the expected value of x, we're going to take the probability that x is equal to 1, which is 0.1, multiply it by 1, add that to the product of the probability that x is equal to 3, multiplied by 3, and add that to the probability that x is equal to 6, multiplied by 6. So explicitly, this is the probability that x is equal to 1 times by 1 plus the probability that x is equal to 3 times by 3 plus the probability that x is equal to 6 times by 6, which is equal to 0.1 times 1, which is 0.1, plus 0.5 times 3, which is 1.5, plus 0.4 times by 6, which is 2.4, which gives us an expected value equal to 4. Similarly, the expected value of y is just the sum over all possible values of y of the probability that y is equal to a particular value times by that particular value, which is equal to, in this case, 0.6 times by 1 plus 0.4 times by 2, which is equal to 0.6 plus 0.8, which is equal to 1.4. In the next part of the question, we're told that the final mark for the unit is obtained by multiplying the value in the first assessment by 8 and adding it to 10 times the score in the second assessment. And we're asked to calculate a probability distribution for z, which is our overall mark. Now, in order to do this, we need to find all of the possible outcomes of z. Now, we're going to need to combine all of the values of x with all of the values of y. So we've got 3 values of x, 2 values of y. So we're going to have 6 possible combinations. So let's take those 6 possible combinations. We have the values of x, the values of the y, and the corresponding values of z. So we need to consider for each of the possible outcomes of x, each possible outcome of y, so we can consider our 6 outcomes. So when x is equal to 1 and y is equal to 1, then we calculate our final score by taking 8 times by x, add that on to 10 lots of y, so 8 lots of 1 times by 10 lots of 1 is going to give us a score of 18. Similarly, when x is equal to 1, y is equal to 2, we get a score of 28, and so on. From this, we can also write down the probabilities of each of the outcomes of z, because z taking the value 18 only occurs when x is equal to 1 and y is equal to 1. So we know that the probability that z is equal to 18 is going to be the same as the probability that x is equal to 1 and y is equal to 1, which is 0.1. Similarly, the probability that z is equal to 28, well, that only occurs when x is 1 and y is 2, so that's going to be equal to 0, and we can carry on filling in our probabilities. In part B, we're also asked to calculate the probability of the individual failing. So in other words, the probability that z is less than 40. But since all of these outcomes are mutually exclusive, you can't get a mark of 18 and 28 at the same time. If we want to find up the probability that the mark is less than 40, we just add up all of the probabilities where z is less than 40. So that's going to be equal to the probability that z is equal to 18, plus the probability that z is equal to 28, plus the probability that z is equal to 34. And that gives us a probability equal to 0.1 plus 0 plus 0.2, which is going to be equal to 0.3. So the probability of getting a mark less than 40 is 0.3. In part C of the question, we're asked to now calculate the expected value of z, so the expected score. And remember, the expected value of z is just equal to the sum over all possible values that z can take, the probability that the random variable z is equal to each particular outcome times by that individual outcome. So in this case, this is going to be equal to 0.1, the probability that z is equal to 18, times by 18, plus 0 times by 28, plus 0.2 times by 34, plus 0.3 times by 44, plus 0.3 times by 58, plus 0.1 times by 68. And that's equal to 1.8 plus 0 plus 6.8 plus 13.2 plus 17.4 plus 6.8, which is equal to 46. The final part of the question asks us to verify that the expected value of ax plus by is equal to a times by the expectation of x plus b times by the expectation of y, where a and b are constant. In this case, well, in this case, our new variable ax plus by was equal to 8x plus 10y. So we'd hope to verify that the expectation of z, which was our 8x plus 10y, is equal to 8 times by the expectation of x plus 10 times by the expectation of y. Now remember from our previous score, so this would be equal to 8 times by 4 plus 10 times by 1.4. 8 times 4 is 32, 10 times 1.4 is 14, 32 plus 14 is equal to 46. So we've shown that our identity holds here.